In this video, we are going to talk about corresponding and alternate angles, as well as vertically opposite angles and co-interior angles. Let's go with some definitions first. So, these are corresponding angles. The color-coded angles have the same measure, so if this angle has the measure A, this also has the measure A. If this angle has the measure B, this also is B, and so on. I generally try to visualize this or express this as, these are eyes looking at in one direction. So you can just find the corresponding angles like eyes looking at in the same direction. So if those angles are numbered as 1, 2, 3, 4, and here 5, 6, 7, 8, then I could easily say angle 2 is the same as angle 6. They have the same color code in here, right? I can say angle 1 is the same as angle 5. Why? The reason is that they are corresponding angles. And all other angle pairs follow as angle 3 is the same as angle 7 and angle 4 is the same as angle 8 because they're corresponding angles. Well, these angles are called as vertically opposite angles, and the color-coded angles have the same measure. For example, angle 1 is the same as angle 3 and so on. Here, the color-coded angles are called as alternate angles. So this angle has the same measure with this one, whereas this angle has the same measure with this one. You can figure this out finding a Z shape here, so that inside this Z shape are the angles which have the same measure because they are alternate angles. These two angles marked are called as co-interior angles, and if this is A, this is B as measures, they add up to 180 degrees. Now, this is easy to prove because I can say this angle is also B because these two are this one and this one. They are corresponding angles, and as you see here, these two make 180 degree angle. So A and B add up to 180 degrees and they're called as co-interior angles. Before we are going on with the examples, I'd like to remind you that these are all valid statements as long as these two lines are parallel. As you can see, those signs here, they show parallel, right? These two lines are parallel. So as long as they're parallel, we can talk about corresponding angles, alternate angles, vertically opposite angles are not a part of this, but we could talk about co-interior angles as well. If they're not parallel, we cannot talk about that at all. Now, some examples. Now, as D is here inside the Z, I can say that D is equal to 131 degrees. Why? The reason is they are alternate angles, and once I have D known, I can just find E, saying 180 minus 131 equals 49. Well, E would be 49 degrees. Reason is supplementary angles. So we never forget to write down the reason, however easy the calculations are. Certainly there are other ways of finding D and E, like you could call this as 131 degrees because they're corresponding angles, these two, this one and this one. And then you can say D and this 131 degree marked angle are vertically opposite. And then you can discuss that these two are supplementary and you can find all the angles. In this example, I can easily go with alternate angles to find K and I, as K would be 44 degrees and I would be 71 degrees. Reason? Alternate angles. For the angle J, you can go like 71 plus 44. This will be 115 degrees, right, when you add them. And you can take away the sum from 180 to find that J is nothing but 65 degrees. So you say that J is 65 degrees. You use the property that all the angles inside a triangle adds up to 180 degrees. Of course, instead of writing this full sentence, you can say angle sum in triangles, or interior angle sum in triangles, or anything which is like that, similar to that. Now it's your turn. Please solve these questions and submit your answers to the online self-check. Thank you.